I'm going to get us started with Sam Ghods this morning. He's the 4th employee at Box.net and is now the Vice President of Technology, where he manages the direction and high-level application architecture for their technology stack. So join me in welcoming Sam to the stage.
Hello? Hello, test. Everybody can hear me? Everybody can hear me? Come on, guys. All right. This is going to be fun. So there we go. So my name is Sam Ghods. I am the VP Technology at Box. And today I'm going to be talking mostly about how we view MySQL as a tool, essentially, as a database. So to get started, kind of give you guys a little high-level overview. What Box does, what our product is we are essentially the simplest way for businesses to access content from anywhere, any device. And basically, the product looks something a little bit like this. You've got your folders and your files, and you can upload and download from a web client or from your desktop sync client or from an iPad or an Android device or anything, really. And you can also collaborate folders with others inside your company or outside your company, anywhere, to any Box user. So that if you share a folder, that folder and all its contents will essentially become part of that other user's account and be able to be viewable and searchable by them. So that's kind of the basics. And to take you back a little bit, about 12 months ago, we had about 400 million files and about 40 million folders. And this is just the metadata, right? We're not going to be concerned today with the actual binary contents of those files. Just each of these, you could imagine, represents a row in a relational database. And basically, the entire thing was sitting on one MySQL database, which, as most of you know, doesn't really scale. We did scale it. Believe me, we scaled it. We added Fusion I/O. We added 100 gigs of RAM. We did the whole, the whole dance. But we knew that we had to go the next level and take it to, web scale, if you will, and make it horizontally scalable and take that next step. So basically, that needs to happen. And who here knows what technology you use when you need to scale? That is a good option. That is a good option. Our customers were not happy with that option, so we had to go to the next one. And everybody knows that to scale, you have to use NoSQL, right? It's obvious. Everyone knows that. So NoSQL is really just amazing thing, right? What's so great about it? Well, it's easy to scale. You just add machines. And the reason you can just add machines is that sharding is essentially handled by the database. The distribution of data across those machines that you want to horizontally scale on is handled by the database. And by the way, just for this talk, when I talk about NoSQL, the specific databases or data stores that I'm talking about are things like HBase, React, Cassandra, basically databases that kind of have these specific attributes. And I know there's a lot of other ones like Redis or Neo4j or things like that, but we're not as concerned with those. We're concerned with those that allow you to really horizontally scale. Basically, they linearly scale, shared nothing, no serious single point of failure, or one that can be essentially accommodated for. And they have some other attributes, like generally they have some simple CRUD operations, create, read, update, delete. Some of them have some more advanced kind of primitives, like maybe you can append to a list or increment a value or something like that, or do a range scan. But generally, they don't provide too much functionality for you. And then finally, they're generally schemaless, where the data that you put in there is kind of seen as an opaque blob to the data store. You don't have a lot of insight into what's inside of there. The database doesn't. So basically, this was the answer, right? You deploy this, and then everything is solved, and you can just scale from there, right? So yeah, so that's really the end. But actually, that's so fast. So that didn't quite work out for us. And what we did instead was we sharded MySQL. So you might be asking at this point, why, right? Or you might not be. You might be still asleep from last night, which is fine as well. A lot of people have asked me why. And there's kind of a specific reason that we found to not move off onto a NoSQL store. And that's kind of the hypothesis of this talk, which is that if you use one, but you need any kind of advanced features in your data store, you end up having to rebuild them yourself from scratch. And that can be a very time-consuming, kind of inefficient process. And if you're willing to do the data partitioning yourself, the thing that NoSQL handles for you, if you're willing to do that, you can get some of MySQL's fancy features kind of essentially for free, or at least the development and the maintenance and a lot of the work that you would otherwise have to do is kind of batteries included. So I'll go through just like a couple of those different features and what we found to be particularly useful out of MySQL and what really kind of encouraged us to stay on the platform. So the first one is inter-row consistency. So when you hear about consistency in like a NoSQL store, they frequently talk about like a single row consistency, right? Like in Cassandra, for example, if I write a value to one node and then I read it from another, how long will it take, or what guarantees do I have that those two nodes will give you the same value? And there's all sorts of different levels that you can figure out in different ways, but there's no talk whatsoever about inter-row consistency. And I'll go through some examples of what that is, but it's kind of fundamentally very, very hard for them to do. So what's an example of that? Well, for us at Box, one thing that we ran into, and it's totally possible your application will have this case, but one thing that we ran into is that file trees must remain consistent. So an example, let's walk through a quick example. Let's say you have a folder A, and inside that is a test file, and two people are trying to upload this test file at the same time, a file with the same name, essentially. That's not really allowed in a file system, right? So you can have your application check to see if that test file, a file with that name exists, and if it doesn't, then go ahead and insert the file. But if two of your application processes try and do this simultaneously, you'll likely end up with two test files because they'll both check, get a negative result, and then decide, okay, go ahead and insert, and you'll end up with two. And you really don't want to, you only want one. So enforcing that is actually quite difficult on your own or in the application layer. And so if your data store can enforce it, it's really, really, really handy. So in MySQL, you can use something, one of the very basic things, a unique index. And that level of guarantee is, can be very, very useful in the application. And even if you don't want to use a unique index, right out of the box, you have another option, was essentially to lock folder A. And you just very, very quickly, and I know this is heresy to say the word lock in any kind of web scale, right? But it's very quick. You just lock the folder. You just check to see if there's anything there. If it's not, you write the row, and then you unlock. And that whole thing takes maybe a millisecond or two. And you end up getting this guarantee of consistency that your app now doesn't have to deal with inconsistent data or broken or corrupted data. Implementing this yourself on a NoSQL store is really, really, really hard. You usually have to implement some layer on top or some other choke point that is probably going to be less efficient than it happening right at the most low layer of your data. So that's one example. Another example for inter-row consistency is modifying data structure in a logging event. So for example, at Box, we want to give a consistent event stream to our clients, okay? And so like these are sync clients or web clients or API clients or things. We want to give them a consistent stream of events that have happened to a specific tree, and we want that to be durable so that if they disconnect and reconnect later, they can get what has happened since I last connected. So to do that, we so for this example, let's say you have folder A and you have test file 1 inside of that folder, and then somebody renames it and changes to test file 2, and that generates a rename event. But you really don't want a situation where you've only modified the tree and not created the rename event, which might happen if you modify the tree first and then your PHP process crashes, for example. And you also don't want a situation where you've only created the rename event but not modified the tree, because all your clients will essentially get out of sync. So to avoid that, we actually go ahead and use MySQL transactions. Again, I'm really sorry, people are freaking out. But this is actually quite useful for us, and it allows us to get this guarantee and not have to worry about it anywhere else. Again, you can build it yourself, but it's a lot of work to either comb through logs to see what either broke or crashed, especially when you've got thousands and thousands of PHP processes or Python or whatever it is, your middleware language processes that may or may not crash at any time or have any problems at any time. This kind of guarantee that you won't do one of these things without the other is actually really helpful and simplifies our app code. The last one I'm talking about for the consistency piece is denormalizations. So let's say somebody deletes folder A, and somebody then tries to access test file 1. Well, you don't want a situation where every time somebody accesses anything recursively under a folder, you have to check all the parents all the way up to see if any of those are deleted, because that would be quite inefficient. So you'd like to actually go ahead and copy this information down to all the rows below you. But I'm sure you can start to see where I'm going with this. Essentially, if you have a problem where only this one's deleted, then again, you have inconsistent, corrupted data, which is not conducive to your app working well. So basically, again, transactions kind of help save the day and allows you to open a transaction, mark these rows as deleted, and then commit that. So we don't use this all the time in all situations, certainly not in all of our app code, but in critical sections where we need this functionality, just having it and having it proven and done and understood is pretty helpful. So another thing I will talk about is indexes. So they really are very cool. They are very cool. Why? Well, they're guaranteed to be consistent. You never have to worry about them. Secondary indexes and other NoSQL stores, you don't really know what's going to happen to them. But here with MySQL, you're not going to end up with a situation where you have something in your index that is inconsistent from your actual database. They're extremely fast, and the big reason for that is because of the data locality that especially helps with sorting and ordering. If you want to order, 1 million rows, you can do that in a matter of, a millisecond or two, which is because it's already ordered, essentially, which is fantastic. And there's not really maintenance required except for that initial alter. Which can be handled through all sorts of different ways, either online schema change or flipping back and forth between masters or things like that. So for us, how do we use this? We essentially use it for if you have, let's say, 10,000 files in a single folder, and you want to be able to get just the top 35 of those files sorted by anything, really, name or updated time or things like that. We don't have to pull all 10,000 of those into memory, sort those, and then display those to the user. We can just grab the last 35 from MySQL, and it's already ordered, and that's managed. And anytime anything changes, that order is rearranged and done for you quite quickly. So that's indexes. Tools is another big one, and this kind of is now on more the maturity and the reliability thread. As these data stores do have some advanced functionality, like HBase has range scans, or Redis has, or not Redis, but I think React has some different ways to append to different data types. As more advanced functionality does exist in there, you generally want to know what's happening in your data store. Let's say the load starts spiking after a code push. What's happening? What is the statistics around what queries are running? How long are they taking? Has there been change? Things like that. And something as simple as show full process list is actually kind of a godsend in a lot of those cases. And MySQL, again, out of the box, it's there, and you can instrument it, and you can do all sorts of things with it very, very easily. And there's already lots of tools that use it. For example, like InnoTop kind of shows you in real time what's going on in your database at a very low level of granularity. So these are some very useful things. Some other stuff, anything that speaks SQL, you can use out of the box. I mean, this is obvious, but it becomes quite painful when you no longer have SQL and everything has to go through, like the HBase client, which then talks to HBase, and then you kind of have to re-instrument all these tools yourself. And then finally, PT Query Digest is a big one where you can get a lot of advanced statistics and knowledge around what queries are running. And we actually, our DB Ops team was able to build a very sophisticated, very cool interface on top. I encourage you guys all to check it out. But which kind of shows you charts and graphs around the information about what queries are running and how much time they're taking and things like that. So then they were able to do this really, really quickly because of a lot of the work that was done before them, which was the PT Query Digest and the parsing and the analysis and things like that. So last thing I'll talk about is maturity and reliability. This is, again, for us, actually, this ended up being pretty much the most important thing. And this whole conversation has really been about the primary data storage, right? What do you use for your core storage of your user content? And I don't really have to list the companies, but it really is a very, very long list. I got lazy. It's hard to actually make a bet where you have millions of customers' data and to move them off onto a data store that has far less production experience and edge cases tested out and just raw hours under the microscope and under constant pressure. It's hard to give that up for a technology that hasn't gone under nearly the same level of scrutiny, so and especially time. So when you're dealing with the crown jewels with the actual customer core data that cannot be recreated or reproduced from any other source, then you really can't experiment and you can't afford to do that. And that was what we found. So you might be wondering, God, Sam, why do you hate NoSQL so much? And I don't. I actually really don't. And a lot of this conversation was around the primary data storage piece. So we actually do use a NoSQL solution in our architecture build, even with all this yelling and screaming. It's like we still actually do use NoSQL in our architecture, and we actually go ahead and use HBase. And the selection process for why we choose HBase is kind of a separate conversation. But it had to do with like how much people experience had with it, how much experience we had with Hadoop and things like that. But fundamentally, what we're using it for is what we find quite interesting, where it's essentially, if you remember the event I talked about earlier, where you want to modify a tree and also log an event at the same time, and we use the transactions for that, right? Well, that individual row, that distinct row that was logged for that tree, we may want to propagate to thousands of users, right? Because all those people might be listening to this specific folder. And so, we might want to do that, and then we also want to do that durably. So anytime somebody connects, they're able to get the full stream of what has happened, and that stream is actually customizable per client depending on what they're listening to. So basically, we have to write out to disk, potentially thousands of different queues for just a few different events that might have happened. That is perfectly suited for HBase. Why? Well, one is that it's not a primary data store, so we can afford to have to recreate the data if something catastrophic happens, something like that, while we get our feet wet, while we productionalize it. Another is that it has a massive, massive write volume, so just the economics of SQL doesn't make sense in that kind of model, and a number of other attributes which essentially make it actually a very, very good tool to use. And I'm not saying it can't be used for a primary data store. I know definitely companies are using it, and that's totally fine. It was just that the way we went about it is that we said, okay, we have to learn this technology first, and this is a great way to learn it. Because you're going to get those random error messages in the middle of the night that nobody really knows how to deal with because of some specific edge case of your workload that hasn't yet been proven out or tested yet. Essentially, you want to be ready for that before your whole company is on the line or your actual data is on the line. So we definitely will consider moving more to it in the future. But we're very happy to be able to get this productionalization experience without having to test it out on our core data. So just some final thoughts. So the first is don't choose a database just because it scales. I think a lot of you guys know this, but what you really want to do, especially in like discussions in your companies and things, is actually understand why does it scale? What are you giving up? What are you sacrificing? And is that stuff important to your application? If it's not, which is totally possible, all the things I said are somewhat specific to Box, and it's completely possible that these things don't apply, and a NoSQL store is an extremely valuable tool. But understand why it scales and what you're giving up. This was a quote from like a Tumblr article recently. I think it just sums itself up very, very well. Database is the last, database especially is the last thing that you want to kind of jump into head first, because you just don't know how these things are going to react, and benchmarks don't really tell you what a real workload will do. If you go into new technology, be aware that crazy things might happen, stuff you didn't expect, stuff that came out of nowhere, random failure cases that haven't been explored or tried out or understood before fully, and you need to be prepared to deal with that, and if you are, then by all means go ahead and use it. And then finally, make sure you're not rebuilding MySQL, because they do a pretty good job, and it's getting faster every day, and that would be a shame. So thank you very much. Oh. And we're hiring, so definitely come. I have to do this, so definitely come talk to me.